Hello everyone. Based on several requests that I was receiving over the past couple of months, I thought of coming up with a end-to-end data engineering project, and that too in the Azure side, right? So in this project you will get a complete idea on how a project is handled in the real world in the industry, right? And this should be really helpful for your interviews, or even if you are working in Azure, this should help you in your day-to-day work. Now, I'm sure most of you would be aware of me. My name is Sumit. I completed my master's from NIT Trichy, and then I've worked for companies like Cisco and VMware. I majorly worked in the big data area. For last 5 years, I have been training candidates in the data engineering space, and I offer an ultimate data engineering program, which is a quite extensive program, 32 weeks program, and that is a program which has impacted several careers and has changed several lives. Right? So you can check that program. The link to the program is in the description. Without any delay, let's get started with the project. So, what is this project all about? So, first thing that I will talk is the technology on which this project is based. This project will be based on Azure Data Engineering Stack, right? Which is a very trending stack, right? So I was getting a lot of demand that, okay, sir, can you develop a project around Azure Data Engineering? So I thought of developing a end-to-end project, taking a real use case and applying whatever I could, right? So this will give you a very, very good idea when you are going for interviews. And even if you do not think from an interview perspective, when you are working in your companies, this should be helping you a lot. Now, what domain we will be working on, right? So there are multiple domain: healthcare, banking, retail, finance, insurance, right? So this will be around healthcare domain, which is a very trending domain. Now, even if you are not from this domain, it's okay because you will get a complete idea about the end-to-end pipeline, which is trending, right? But for people who are from healthcare, then you can relate with the data sets and all also. So this project is around healthcare revenue cycle management, right? Commonly known as RCM, healthcare revenue cycle management, RCM, right? And I'm sure if some of you are my students working in healthcare domain, many of you would be working on RCM domain. By the way, if you do not know about me, my name is Sumit, and I offer data engineering programs. Right now, a very trending program is the Ultimate Data Engineering Program. And in case if you want to know more about it, you can check under the comment section. You can check under the description of this, right? Where you will get the link to my website. So, anyways, let's get started. So, what is this RCM and what exactly we have to do? So, let's understand about this domain a little bit so that you get a context on what we have to work on or what problem statement we are going to solve. Okay. So, RCM is the process. RCM is the process that hospitals use to manage the financial aspect. So I will first write it and then I will explain because I want to go little slow on the domain side because someone who is not from this domain should not get lost, right? So you should be able to understand it very well, and I will try to talk in layman terms. So RCM is the process that hospitals use to manage the financial aspects financial aspects, right? And the financial aspects start from the moment a patient schedule an appointment. Let's say if someone is going for let's say someone is getting a viral fever, someone visits a hospital. From that time onwards till the time the doctor actually gets paid, right? So the end to end cycle, right? From the time the patient schedules an appointment till the time till the time the provider gets paid. Provider, in the sense, you can think of a hospital or a doctor. That means end to end. That means first a patient pays to the hospital, and the hospital internally will pay salaries and all, and all of that stuff in between, right? So there is a lot. I'll talk about it, but it's mainly to deal with these financial aspects about the patient paying the hospital, and then hospital has enough of revenue supply so that they can manage their things. So I want to give a simplified breakdown for this. So here is a simplified breakdown, and I am writing this note so that these notes become handy for you, right? So how this starts? It starts with a patient visit. It starts with a patient visit, right? The process starts with a patient visit. So when a patient visits a hospital, it can be a big hospital or it can be a small clinic, whatever is that, their details, the patient details, like the insurance coverage or whatever details are there, are collected. So patient details are collected by the hospital or clinic. Now, why these details are collected? So mainly I am talking about the insurance details here. It will be other details also, but insurance details is what is very, very important, and these details are collected. Now, this ensures that the provider in the sense here, the hospital. So this ensures provider knows who will pay for the services. And I am trying to use the terms which are used in this particular domain. So provider in this context will mean a hospital, but in some context it will mean the doctor also. So patient is a patient, as you know, but provider is something that you might not understand. So I am giving you an idea that context wise it will be either hospital or a doctor, the one who is providing the services. So this ensures providers knows who will pay for the services. So who will pay? Either it will be insurance company who will pay, or the patient will pay, or both will pay. That means some part the insurance will pay and some part you will pay. Because, for example, you might, let's say, go through, or someone goes through a surgery, and the bill for that in India, let's say it is 3 lakh, right? Or let's say if you talk about US, even though the project that we are building is a US based project, think that it's a US based hospital that we are referring to. So let's say that the cost of this surgery is, let's say, uh, 20,000 USD, right? Now out of this, let's say 15,000 USD, the insurance company will pay, insurance provider will pay, and 5,000 USD the patient has to pay, right? So, or otherwise, might be insurance company will pay the entire amount, or the patient will pay the entire amount. It can be various scenarios based on the insurance policies and all. That's why it's important to know the details of the patient, that what insurance that person hold and all of that. So it starts with a patient visit, where the patient details were collected by the hospital, or the, we could say, the provider. Okay. Now second step is what? Hospital will provide the services. Services are provided, right? So the doctor provides treatment, and the hospital keeps a record of everything done. That is the tests, the procedures, the medications. So that means all the services are provided by the doctors and hospitals. Okay, that's good. Third thing, what happened? The billing happens. The billing happens. Okay. In the billing, what exactly will happen? The hospital create a bill. I'll write, the hospital will create a bill, right? Uh, for the services provided, and send it to the patient insurance company to request for the payment. So they will create a bill and will send it to the insurance company if they are about to pay, or if there is no insurance, then the patient will pay whatever. So they will create a bill and will give it to the patient or the insurance company. Fourth, what will happen after this, in this thing process? claims are reviewed. So if this goes to the insurance provider, the claims are reviewed, right? The claims are reviewed. That means the insurance company review the bill. Insurance company review the bill or invoice, whatever it is, to make sure it follows their rules. Because insurance company also has certain norms that how much they can pay, what surgery it was, and they have lot of rules and regulations. So it will see that whether it's following their rules or not. So sometimes they approve the payment, but other times they might reject or deny it due to whatever errors or uncovered services. So they might pay full. So they might accept it, or that means pay in full or partial or decline, whatever, based on whatever policies they have or whatever the insurance policy person holds, right? Now, after this, what happens? The payments and follow ups will happen. Payments and follow-ups. That means once the insurance pays its share, the hospital may bill the patient for remaining amount. That means it might happen that insurance company pay a certain amount and the patient pays for a certain amount. So that will happen that once the insurance company pay its share, the remaining will be asked from the patient itself. And if payments are delayed or denied, the hospital follow up for the issues, right? The hospital will follow up to the patient for the payment, right? So I hope you can understand that uh, if the uh, if partial payment is done by insurance company, or let's say no payment or partial payment is done by insurance company, then some portion or full portion will be given by the patient. Then some portion or complete thing, whatever is the case, is given by the patient, and the hospitals will follow, and the hospital, that means technically we say the providers, will follow follow up for the payment. That's what the follow up means. And then what will happen after this? Tracking and improvement. Tracking and improvement. What does that mean? So hospitals constantly monitor the process to ensure they are collecting payments efficiently and reducing mistakes like declined claims and all, right? So they do not want to lose business. So they want to make sure they collect all the amount. It's not that some patient become defaulter, they are not paying and so on, right? So they want to track it properly, follow up properly, and want to improve the process in case if they feel they are losing money and all, right? So this is how the process is, and people from healthcare background would be aware, but I want to give you a context because some of you will not be from healthcare background, right? So in a nutshell, if I have to say, rcm ensures rcm ensures the hospital can provide quality care quality care while also staying financially healthy financially healthy, right? That means financially healthy in the sense it should not happen that they mismanage things and the patient has to pay, but that patient is not paying and all, right? They are not following up. So rcm ensures that I mean the hospital stays financially healthy so that they can pay to their doctors, they can pay for instruments and all of that, right? That's the whole purpose about rcm. So I hope this is clear. So it's about making sure everyone, patients, insurers, right, and the providers, that means the doctors and all, gets paid on time, or whatever payment they have to do, that's collected on time. So basically, as part of RCM, we have two main aspects, right? We have two main aspects. Number one, We have accounts receivable. That means the payment that hospitals have to take. Accounts receivable, right? Also called as AR. That means the money that they have to collect from the patient or the insurance company, whatever. And then second is accounts payable. That means whatever they have to pay to their doctors, their staff, and the instrument, whatever they have to pay, right? But most important component among this is accounts receivable, and whatever we will be doing in this project will be towards accounts receivable, so that the hospital remains financially healthy, right? There are two parts always, right? Getting money and paying money. So as a hospital, whatever money we are getting, they are getting is accounts receivable. Whatever the money they are paying is accounts payable. So we are more concerned about accounts receivable in this case. So AR is the most important and a key focus area, and the project will be inclined more towards it. Now, in this entire process, you have to understand one thing, that what's the risk factor. What does hospital feel is the risk factor? Is insurance company paying a risk factor? No. Those companies that's dealing a kind of business to business, and that will happen properly. But the risk factor comes when patient has to pay from their pocket. So patient paying is often a risk, right? That's a risk. That means if patient has to pay the complete amount or a partial amount, then that's a risk. And if the money does not get collected, then it's kind of a lost business, right? So I'll talk about scenarios when patient has to pay. Scenarios when patient has to pay. See, a case when insurance company pays the entire amount, that's the best for the hospital. Hospitals can even make more money, put make more but higher bills and all, and the money will get paid on time. But the main issue lies when either a customer, I should not say customer, rather a patient has to pay in full or partial amount. So let's understand the scenarios when patient has to pay. So what generally happens these days, this insurance providers, right? They offer a very fancy schemes saying, oh, now you can get an insurance in this much less amount. But when we talk about low insurance, right? It looks fancy to the patients when they are getting that insurance, but there are a lot of hidden terms and conditions, because when you go with low insurance, right, these people shift most of the burden. These insurance providers uh, put most of the burden on patients itself. That means in their clauses, it will be written that, oh, for this surgery, half of the amount patient will only pay, or there will be certain things which will be deducted, right? All of that. So sometimes we do not have a look, and then we think, oh, we are getting insurance at the low cost, and let's take. So nowadays, because of those kind of insurance, patients have to pay from their pocket, and then that becomes a risk to the hospital, right? I hope this is clear. Now, these low insurance plans are attractive at first, but many consumers don't fully grasp the implications of their deductible until they get the bill. Simple thing. I hope this makes sense to you. Now, there can be some private clinics where, I mean, insurance they won't accept, let's say, right? Or some dental treatment, right? Dental treatments are also very costly, where insurance claims cannot happen, let's say, right? There will be certain insurance policies where deductibles are there, where some things like surgery material and all, gloves and all, the insurance companies do not pay, right? So all of that. So such things are the times when patient has to pay from their pocket, right? So this is the thing. Just have a look of what I have written. So always the thing is, hospitals want to have a healthy accounts receivable here. That's the whole thing, right? They want to. They want to make sure they bring the cash, that means collect the money from the customer or the patient. And two objectives for account receivable. Two objectives for accounts receivable, right? That is, first of all, the patient should not default the money, right? That means they should pay. And moreover, it's not just about paying, but they should pay on time, right? So also minimize the collection period. It should not happen that the patient is paying after 5 months, because in 5 months, let's say the money was supposed to be 10,000 USD. After 5 months, as per the inflation, this 10,000 USD will be seen as less, right? So that's a loss to, I mean, that's a loss which you will not directly see, but that's a loss, right? So that's the thing. I hope this makes sense. Now, as per whatever analysis that has been done by some organizations, what they feel is the probability of collecting your full amount decreases with time. That means if you are able to collect early, that's better, because if you're not able to collect in 12 months, then there is no guarantee whether the patient will pay or not. Right? So, as per this, whatever stats, 93% of money, right? 93% of money due 30 days old. That means that means whatever is under 30 days old, you will be able to collect 93% of that. 85% of money due 60 days old. That means a hospital will be able to recover approximately 85% of the money which is 60 days old. And as you go beyond 3 months, let's say 73% of money due 90 days old. So this clearly shows that as and when the patient kind of delays the process, the chances of them paying becomes less, right? So I mean, we can always calculate certain metrics in order to see, for example, the metrics or the key performance indicator KPI to measure uh, account receivable and set benchmark. I will show you certain things, right? So there are certain key performance indicators or things that you can calculate to understand, is are you having a healthy account receivable or not, right? So I will just tell three of those, but there are many such KPIs, right? Account receivable greater than uh, 90 days, right? I'll tell what exactly that means. I have a link actually. I have a link. I'll just show that to you. This link I'll open. So I have opened this link. You can also check. I will mention it in the description. And I have taken all of this, whatever I am talking from these places. You can see even these numbers, right? Whatever I was mentioning, right? The probability of them paying will become less, right? You see this 30 days still you can recover, 60 days less, 90 days even lesser, right? And account receivable greater than 90 days. What does that mean? Accounts that have aged over 90 days are at higher risk for going uncollected. You know that, right? That means someone who has not paid for 90 days, there is a chance that they will default, right? Therefore, it's very important to keep track of how much money is moving into this aged category, right? Month on month. So, greater than 90 days equal to account receivable greater than 90 days. That means how much money is there which is sitting in this bucket which is older than 90 days versus how much total account receivable. That means, let's say, you have to collect let's say a million 1 million USD, right? Total account receivable for all accounts is 1 million USD, just an example. And out of that there is 100,000 USD which is older than older than uh, older than I would say 90 days, right? Then what does that mean? That means 100K divided by 1 million into 100, right? That's the percentage, which is 10%. 10% of your total money which is pending is older than 90 days, right? So your account receivable greater than 90 days become 10%. You can see this. I hope this you will understand. You can check a lot, right? So there are a lot of such key metrics like this. I hope this is clear. And days in account receivable. Let's say I'll talk about another matrix, days in account receivable. So uh, consider, let's say, so I mean here, let's say you set 10% benchmark, and now you see that, let's say your 200 USD is older than 90 days. That means if 200K, that means 20%. But your benchmark set was 10%. So you will check with your team what's happening, why it's going wrong. So this kind of metrics, that's why it's very, very important, so that account receivable is proper, healthy. Now, days in account receivable, what does that mean? Let's say you have your hospital has collected or raised bills of around, I would say, let's say, 1 million USD in 100 days, last 100 days, right? So 1 million USD divided by 100 days, that means per day the collection is 10,000 USD, right? Per day the collection will be 10,000 USD if I see that on an average, right? Now, if you see that your total account receivable, the money which you have to get is, let's say, I would say, let's say, uh, 40 or 400,000 USD. That means if 400,000 USD is account receivable, the money which you are about to get, that means it's a money which you have generated in 40 days, right? So it is 40, this AR, days in AR is 40 days, right? Days in AR, because per day collection is 10,000 and 40,000 USD, right? 40,000 USD is pending. Just have a look. 400,000, sorry, 400,000 USD is pending. So it is something which your hospital would earn in 40 days. So 40 days worth of money is pending, right? So you can set a benchmark. Let's say if this is AR is under 45 days, then it's fine. But if it goes more, then we will just check our processes, are that fine or not, right? So this ways there are a lot of KPIs, right? You can check that out. If you see this days in AR, net collection rate, right? You can see multiple things, that okay, you have to collect, let's say, 1 lakh or 1 million USD, and you are able to collect almost 0.99 million USD. That means around 1%, it went in a way that people are not paying it, it's gone as bad, right? So that means your account receivable or net collection rate is 99%. So that is good. So you can have set your benchmarks here, and there are many other metrics which you can see. So you can check this document, very, very interesting document, and this will give you a clear idea on what benchmarks you can set, what kind of KPIs you can have in the end in order to make this process strong. And there is another link also. I will also keep this as part of your description of the video. These two are very, very informative documents. I have collected all this information from here. So you can see all these KPIs are mentioned. You can have a look and you will get more about the domain. So that's about the entire domain which I would have to say, right? I hope this makes sense. I'll close these documents now. I'll close these documents. Now you should be good, and you would have understood about the domain clearly, right? Now, as a data engineer, what do we have to do? What do we have to do? What do we have to do as a data engineer? We said we will be building a data engineering project. So, as a data engineer, what role are we going to play in this? That's what we have to understand. So we will have we will have data in various sources, and what data I will show you shortly. I will show you that data shortly, but we will have data in various sources. Now, as a data engineer, we need to create a pipeline. Data engineers create a pipeline, right? So, as a data engineer, we would be creating a pipeline. What that pipeline will do? This pipeline we will create so that we end up creating facts and dimension table at the end. The result of this pipeline, I'm not talking about what we will do in this pipeline, but the end result of this data engineering pipeline will be fact tables and dimension tables. Fact tables and dimension tables. And these facts and dimensions will help the reporting team, people who is doing the analysis and reporting, working on visualization. Those people can take these fact tables and can create reports and generate these KPIs, right? Will help the reporting team to generate the KPIs. Just like I have mentioned, you remember some of the KPIs, account receivable, which are more than 90 days pending. That means you will say 20% of my money which is pending for the hospital is more than 90 days old, right? So you would have set up a certain benchmark, but how do you calculate that 20%? Using this, whatever tables we will generate in the end as part of this entire pipeline, right? So all these KPIs can be calculated from this final tables that we will have. So basically, as a data engineer, we need to enable the reporting team so that they can take these tables and do whatever stuff in order to get the KPIs right. Right? So let me now talk about the data sets that we will have. So we have EMR data, right? So I will talk about the kinds of data, right? EMR data, claims data, and then we have the NPI NPI data, and then we have ICD codes, right? ICD data, I would say, right? I will show all of that to you. So EMR data is very very important. Which is, what is EMR? I mean, in case if you are aware of AWS tag, do not think that it is Elastic Map Reduce, right? So this is a domain related thing, and it stands for electronic electronic medical records, right? So nowadays everything is digitalized. So whenever you go to a hospital, right, for the first time, your details will be stored in a patient's table, right? Doctor's detail will be stored in a. So I'll write it. So in EMR data, you have multiple tables. So we have, let's say, patient's table where the patient details are stored. Then we have providers table. Always remember, providers is the doctor, right? So doctors data will be stored in this, that what doctor and in which this doctor is specialized. All the doctor related details are there in provider table. And then we have department. So every hospital will have certain departments like ortho, or apart from that, dermatology, whatever, right? And then we have transactions table. Transactions is, I would say, so there are two things: encounter and transaction. I'll explain you. Let's say you are having a viral fever and you go to a hospital, let's say, right? Then it's a encounter they will mark, right? That means the uh, uh, first time you visit the hospital for that particular thing, for this new thing that has happened, that's an encounter, and they will associate you with a doctor, and also that's the encounter. Now, for that encounter, right, for that encounter, there can be multiple transactions, that you pay the doctor fee, you pay for the medicines, right? So there can be multiple transactions related to that encounter, right? And that means whenever you go to hospital, they give you a file, right, for that particular thing, and then they keep on I mean, adding to that file, let's say, you showed to a doctor today, tomorrow also you are showing, then the file is the same. So that think it as a one encounter, right? Even though you go for 3 continuous days, it's just one encounter, but there can be multiple transactions associated. You might be paying for, let's say, physiotherapy, for some medicines, for consultation. There can be various transactions involved, right? So encounter is one for that particular case. Transactions can be many. And other tables you understood: patient, provider, department, right? I will show all of these tables also to you shortly. So all of this EMR data is stored in a database. All of this EMR data will be stored in a database. In our case, we will assume that this is stored in Azure SQL DB. Azure SQL DB, right? And I will show you these tables now before we proceed. So I will go to my Azure account. You can create a free trial account or paid account. If you use it wisely, you will not spend much. I have created a database, Trendy Tech Hospital -A, Azure SQL DB, right? SQL database. Now let me connect to this. I will say query editor, and I will just connect to this. So this will be connected. Let's wait until we are connected to this database. I want to show you what tables we have. So basically, this is a EMR database, right? Where electronic medical records are stored, and these five tables. So data will be stored in form of these five tables: patient-related data, doctor-related data, transactions, encounters, and department. So now, I mean, before it loads, think of it: which tables will be bigger, which will be smaller. Patients table, there will be new patients, so this can still be a decent size. Providers will be a very small table because there will be hardly few doctors in a hospital. Department will be a very small table because there will be few departments only. Transactions will be a huge table. Encounter will also be a huge table. So the biggest table among this will be transactions idly, and the second biggest would be encounter, I would say. Then patient, and of course this provider and departments are smaller, right? So one patient over the year can have many encounters, right? That means this person might have fallen sick 2 times, so two new files would be created for that person, right? But in each time, that person would have done multiple transactions, whatever, right? For this medicine, for this physiotherapy, consultation, whatever it is. Okay, so we are now logged in. I already have these tables, right? Think that this is at the hospital end, and we have five table: department, encounter, patient, provider, and transaction. Now I will show you the data. I'll show you the data. So let me show you for department. It's very simple. Department will not be much. Department ID and the department name: emergency, cardiology, neurology, whatever, right? Encounters. Uh, so before encounter, I will show you patient, the smaller tables relatively. So we have patient ID, first name, last name. This is a sample generated data, by the way, right? Middle name and SSN number, just like we have Aadhaar and all, right? Same way, a unique number for a patient. Phone number, gender, date of birth, and the address of the person. And when this record was modified, might be the address changes and all, right? So this record will be modified then. Then we have provider, that means the doctors. Provider ID, the doctor ID, it means first name, last name, the specialization of the doctor, the department for this which this doctor works, and the NPI. So NPI is basically a national provider identifier, which is a 10-digit number, right? That uniquely identifies healthcare providers in US, right? So this is a unique identifier for each doctor, right? And we can get it through a public API also. So NPI is a number which uniquely identifies each doctor. Okay, then let me show you encounter. encounter ID, patient ID, right? Of course, because for which patient this file number is, right? Encounter date, inpatient. So there are various encounter type: inpatient, outpatient. So basically, one of them is when the patient has to stay within the hospital for night, right? Like they take a bed and all. And one is when they visit and they come and visit on the same day, right? So inpatient, outpatient, and routine checkup. Telemedicine means a phone call, right? Routine checkup means person comes who comes regularly, just randomly they are coming. They do not have any issues, but they are just coming. Emergency, right? All of that you can see. Different encounter types. That why this person has come. Provider ID, that means to which doctor they have been. That means first time when you, let's say, have a fever and you visit a hospital, which doctor, I mean, they have suggested, and to which doctor you are going to show. That's the provider ID. Department ID, that means to which department you are showing, right? Let's say general physician, right? uh, and doctor name, and the procedure, what will happen, and the date on which this record is inserted. That's encounter. Now transaction. So transaction ID, transactions is related to encounter. So for one encounter, there can be multiple transactions, right? And of course, the encounter is related to a patient, provider ID, department ID, the doctor involved, department, the visit date, right? So let's say you visit today, right? And the service can be the same day or next day. See, these dates are messed up because the data was created and these dates are messed up. Ideally, the service date should be equal to visit date or after, right? It cannot be before. In this case, you see before, so that's wrong data generated. But think it that service dates has to be equal to visit date or after visit date, and the paid date also is same, visit date or after that, right? On which date this transaction is paid. The visit type, was it a routine visit or emergency visit, follow up visit, whatever. Amount, right? Total amount for the bill, the paid amount, how much they have paid, right? Amount type, right? So whether insurance company is paying, co-pay means insurance is also paying and you, the patient, is also paying, right? Both are paying some amount, right? Partial amount. Medicare and Medicare and Medicaid, right? There are two different things. These means, so just like in India, we have government some yojana, right, where they say 5 lakh scheme from government side. Same way in US also, it is Medicare and Medicaid. One of them through the central agency, one of them through state agency, right? So that's what these are different through government, central government or state government, right? And the claim ID, payer ID, procedure code, ICD code, right? So, I mean, this ICD code basically it can be mapped to the description of it. That means this code would mean some of the code, let's say it means that okay, this is, let's say, a typhoid, right? So later this ICD code we can pull the data from a API, and then this can be mapped to a particular description of disease, that okay, what exactly is the disease, type of disease, right? I hope this is clear. So ICD codes are a standardized system used by healthcare providers to classify all of this, right? So based on this code, we will understand that what disease it is. So we will see that how we will map to the actual disease, right? Line of business, Medicaid ID, Medicare ID, right? If person is holding any of this, right, government IDs, then that, and the time when this record came. So I have given you some idea about these tables so that you understand what kind of data we have as part of EMR. Now, interesting thing, there are two databases. So EMR data, let's say if you are from India who is watching this video, then you understand that if you're staying in Bangalore, there is a chain of hospitals called as Manipal Hospital, right? Hospital. Now, let's say they initially have one hospital here in Bangalore, then they would have second hospital, then they would have third, then they would acquire, let's say, something else. I know recently they acquired a hospital called as Columbia Asia, right? So that will also come under them. Now, what if, let's say, this Manipal hospital have slightly different table structures. These five tables they have, but they have different column names and all structures. And now when they acquired Columbia Asia, their patients, the patient details from Columbia Asia will also be now associated with Manipal Hospital. Now there can be chance that this patient's table has different number of columns, or the column names are different, or more interestingly, what can even happen, let's say, if I show you this, if I show you the data for patients, right? Let's say we have this patient ID. Now consider somehow the patient IDs for Columbia Asia and Manipal Hospital were same, like it was 101. Now, how you will identify what is that? So, how you will try to build a common data model later, so that you try to uh, 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 you should not face these difficulties, that how do you merge these two schemas together, because they might be using different column names, or if they are using same column names, might be they are using the same patient IDs. Then how will you know which patient ID is coming from hospital A and which coming from hospital B if the patient ID is the same, right? So we would, that's where I am taking two hospitals to showcase a common data model later. So we will be taking hospital A and hospital B. Hospital B. Think that there are two different branches of a hospital in Bangalore, right? But they have slightly different schemas for some of the tables, and some of them have like same patient IDs. Then we would implement a surrogate key later, so that we are not dependent on that, right? So we would implement a common data model later. That's important thing. That's why I have taken this scenario. So that's where, if you see, if I go back now, if I go back, if I go to home, you see I have two different databases: Trendy Tech Hospital A and Trendy Tech Hospital B. And this hospital B has same number of tables, but I will slightly modify the schema so that later I show that how we merge these two, so that we do not face any difficulties later, right? So this also has same number of tables. I will just show you quickly. I'll quickly connect. This is going to be really really interesting, right? Because that's how things work in industry. I mean, if I give you a dummy idea, then it will not suffice your purpose. So let's say this, all these tables are there and some data is there. Some data is there. You can see. I hope you can understand that. So we are good with both these. We are good with this EMR data, and we understand there are two different databases. So hospital A data is stored in a different database, right? Which is Trendy Tech Hospital A, Trendy Tech Hospital A, and this will be in Trendy Tech Hospital B. Two different databases are there. That means two different instances of Azure SQL DB, right? Both of them have five tables. So that's my EMR data, which is very, very important data. Now this will be in the form of tables, as you understand. Now other kind of data will be claims data, which your insurance team will send. Insurance company or the payer, we say them as payers generally. The payer will be sending us this data, and they will upload in the form of flat files. They will upload in the form of flat files, and they will put it, let's say, in our specified container or specified folder in our data lake, right? So what we have done is, we have created a data lake, we have created a storage account, Trendy Tech ADLS dev. You see a normal storage account. You can create. I'm not creating things here, because if I create, it will take too long. These are simple things, right? I expect that you know some level of uh, Azure Cloud, so that you can create these instances at least, right? So TTADLS dev. Now I go to containers, and here there will be a folder called as landing. Right? Do not worry about other folders. So there will be a folder called as landing. In this, these files will be uploaded by the insurance company, and for each hospital they will upload. Right? I will just show how it looks like. A CSV file, flat file. That's why I say as a flat file, it's a CSV. So the claim, right? Claim ID, transaction ID, patient ID, encounter ID, provider ID, department, service date, claim date, payer, right? And claim amount, paid amount, claim status, right? I'll talk more about this, but you understand that this is related to the insurance, that have they approved, if approved, how much amount, and so on, right? So we have this data which will come in the form of flat files, and this you think that they will send it monthly once. So till now we have seen two different data sets. One is our EMR data, which is in our database. We have two different databases. That means two different instances of EMR running. And we have claims data, which insurance company will be sending in the form of flat files. They will upload it in a folder. Right? What folder I will again show later, but to be at a very high level, lending folder. Right? Okay. Now there are two other kind of data that we will be using, and that is NPI data, right? So claims data, you understood, flat files which will come from insurance, that is providers. Now NPI data, what is that? National provider data, or national provider identifier. So you remember that I mentioned each doctor is given a 10 digit unique code or number, and national provider identifier, right? A unique number that identifies each doctor. And there is a public API available for this. Public API, we can call that and get all the list of doctors from there, along with the NPI, this thing, details. So complete details of doctors, that means the providers, is we will get from NPI, this thing, API, public API. I'll show that API also later. You can see this NPI data. How does this look like? Right? NPI ID, first name. I have some sample data. First name, last name, position of this person, organization name for which this person is working, last updated, when this record was last updated, and is current flag true, right? Like that. So this is more about the provider data, right? I hope this is clear. This is about NPI. Now, in case if I am, see, I am not from healthcare domain. Whatever I could understand, right, I am trying to explain. And if you feel somewhere I am incorrect, then do mention in comments, right? So because let's take it in a very constructive manner so that we all learn, right? So in case if you feel somewhere I am not clear with the domain like NPI and all, you can always feel free to mention in the comments so that everyone can learn, right? But as per my understanding, I am talking about these things, and can be a chance that I'm sure I would be 98% correct, but 2%, if there is any issues, you can always mention in the comments so that everyone learns from that, right? So NPI data we have seen, and we have ICD data. What is that? So we have ICD codes, which is nothing but a standardized system used by healthcare to classify. I mean, uh, that means you have a code like this. For example, this is a code, and then we have the description. That means cholera due to whatever, right? For example, this code you see, if someone's diagnosis is this code, that means it is typhoid fever. So we have a API which gives us this kind of mapping. That means the ICD code and description. So we will run these two APIs also to get this data, right? NPI data and ICD data. So I will write ICD codes are a standardized system used by healthcare providers to classify and to basically map diagnosis codes and diagnosis code and description, right? A mapping kind of that you will get from this ICD data. So there is a API for that. There is a API that we will see. But in this particular part one, so as I said, this project I will be having two parts. This is the part one, and in this I will mainly talk about our EMR data. So you kind of understood that we have now EMR data, which is in database, right? We have claims data, which is in form of flat files like CSV, and then we have data coming through APIs, right? Which is nothing but NPI, right? And our ICD data, ICD codes. These are the data sets at a high level that we have, right? So I am sure now you are clear with whatever data sets that we have. So with this, you understood about the data sets very properly. Now, I will talk about the architecture that we will be following in this, right? So, the solution architecture. So, we will be following a medallion architecture, by the way, right? I hope you know what is a medallion architecture. In case if you do not, I will just give you an idea what is medallion architecture. So what happens in a medallion architecture that let's say let me tell that let's say if you have a landing zone or a landing folder. So just like if you go to our storage account, right? If you go to our storage account, by the way, the storage account that we create, if we turn on this hierarchical this thing on, right? So hierarchical namespace enabled, then it will become a ADLS Gen 2 account. Otherwise, it will be a normal blob storage. So it is recommended to turn that on for big data analytic workloads and all, right? ADLS is quite performant that way. So I have created a storage account, and in that, if I go to containers, you will see there are multiple containers. I have bronze. Ignore that config for now. Bronze, gold, landing, silver. So I'll write landing, bronze, bronze, uh, silver, and gold. Right. So if I have to draw a line or lineage, it would be this way. Right. What happens first, let's say you have some of your data or all of your data in the landing folder, right? And then you try to move it on the right side. So from landing you move it to bronze, from bronze to silver to gold, and you keep improving on the data in terms of cleaning, in terms of better data and all of that, right? So I'll talk about it. So right now I mentioned what data sets we had: EMR, right, and claims data, right, and then apart from that, codes, right. So we have this data. So EMR was in SQL DB, Azure SQL DB. This was flat files, and this also we can get as form of files and all. Like we can run the API and we will get it, right, in terms of files. Now this we can get in some other format, not flat file. Let's say we can get the data in Parquet format using the APIs. Let's assume that, right? I have to check, but let's assume. So now in your landing, if I show you this landing, they will the insurance provider will be putting these files here, right? Insurance provider will be putting the files in landing. So that's fine. That are flat files. Now, so in lending you have insurance files, but what about this EMR data? EMR data is in database, and now you when you bring it or when you try to load it, you will directly bring it to your bronze layer. this landing zone will not be coming into play. So landing zone is only when the data is in form of flat files. So if it is in the form of flat files, we are keeping here flat files initially, right? And then uh, in my bronze layer, I will keep it in the form of parquet files, right? Parquet files. And in my silver layer, I will create delta tables. I'll create delta tables. I'll explain more, right? In silver layer, I will create delta tables, and in gold layer also there will be delta tables. Delta tables, right? Databricks delta tables that way. So not necessarily everything will be in lending, right? So the insurance company loads something in lending in form of flat file CSV and all, then we take it to bronze to silver to gold. But this EMR data, it will directly, when we load it, how we will bring it, we will ingest it through Azure Data Factory, and then when we do it, we will directly bring it to bronze layer in the form of Parquet files, right? So bronze layer will hold everything in the form of Parquet files. And when we get this codes and all, when we run the API, we can directly get it to bronze layer. So lending zone is only for insurance data in our case. Otherwise, uh, the EMR data which we get from tables and the codes like ICD code and NPI, we directly get it to bronze layer in form of Parquet files, right? And then we take it to silver. What we do from bronze to silver, we basically, I mean, I will write it. I'll write. So bronze has Parquet format, is in Parquet format, and you can think it like source of truth. Source of truth. That means if sometime you have confusion in silver and gold, and you want to go back to the actual data, you go back to bronze layer. Now, talking about silver, from bronze to silver, what changes? Basically, we do data cleaning. While loading to silver, before loading it to silver, we do some cleaning of data, cleaning of nulls, and data quality checks. We might enrich the data. I'm talking in the general sense. We might enrich the data by joining it with something and all, right? Now, in our case, we will also implement a common data model because we know we have data from two different hospitals, and we will assume that patients table have different column names and the patient ID might be similar. So we will implement a surrogate key so that we can properly merge these two databases without any problems, right? So we will implement a common data model. So before loading to silver, we will implement a common data model, right? CDM. Also, the we know that okay, the patient detail can change, right? That means the address can change, the doctor details can change, and so on. So we will implement a SCD type 2 so that we maintain the history also. So you know that we have different kind of slowly changing dimension. For example, in our case, a patient table, provider table, all of these are dimension tables, right? Kind of. So the things can change and we can end at the previous record and the new record will come. So we maintain the history. We will talk about SCD type 2. So we even implement SCD type 2 so that we maintain the history. So that's our silver layer, right? And once the data is in silver layer, data is cleaned, enriched. It is, I mean, it follows a common data model, and it has previous history also, right? Using SCD type 2. Then final is gold layer. Gold layer. In gold layer, I mean, gold layer is basically we, if there is any aggregation to perform, we can do that. But in our case, what we will be doing, not aggregation, but aggregation is more in a general sense, I am saying. But now, what we do, finally, we want the answer in the form of facts and dimension, fact table and dimension table, so that my reporting team can build their KPIs, right? Can understand all of that metrics. So I need to build the right data model for facts and dimension, and I will show you how exactly we build that, right? And my reporting team will take this and can whatever build reports on top of it. So I hope this is clear. And you see, the more you go on the right side, the better you have the data. And each of these layers serve different personas or different kind of person. If you ask me who will be the end user for gold, I would say business users. Business users who have to take business related decisions, right? Gold layer. Now, who will be using data from silver layer? It's more clean data. So basically, if there is a data science team, right, data scientists can use, machine learning experts, right, or even data analysts, because they need still the granular level data, right? They do not need aggregated data as in gold, but they would need granular data, but they need clean data, right? So each layer serve different personas or help different kind of persons. Now, bronze layer is for whom? I would say bronze layer has raw data as such, source of truth. So ideally a data engineer who can implement whatever they want, right? Each layer serves different personas in the medallion architecture. Now I have mentioned three layers. Sometimes people might say instead of bronze raw layer, and they can have 4 or 5 layers, but each layer would serve a different use case, right? So there is no hard and fast rule that there can be only 3 layers in this and so on. In our case, landing folder, if anything is there in landing folder, that will be flat files. In my bronze I will have parquet files, right? I do not have tables still in bronze. And from silver layer onwards, I will create delta tables, Databricks delta table, right? From this layer onwards, I will have tables. I hope we are good with this. Now, I will show you how exactly this high level architecture looks like, right? So you see this. We have hospital A, Azure SQL DB, hospital B, Azure SQL DB, two databases. Again, we have a folder like a container in our ADLS Gen 2, which is our data lake, right? Where we get the files from the payer. Payer is nothing but your insurance company. And we have public APIs, ICD code and NPI, whatever, right? This public APIs. Now, from the databases, EMR data, directly when we get the data, how we will get through Azure Data Factory. Azure Data Factory is for data ingestion, right? We can use Azure Data Factory for data ingestion, and this data will directly come in the bronze layer, and then it will come in the form of Parquet files. That means we take the data from databases, put it in our bronze layer, bronze folder in the form of Parquet files. It will not be there in landing. Now, pair files, let's say we have given the access to the insurance company for the folder, landing folder, they will dump flat files in CSV format every month. Right? So data is in CSV. We take the data from landing folder CSV format, put it in bronze and convert it to Parquet, right? Again, we do this using our whatever we can do through Databricks or Azure Data Factory, whatever. We will talk about it later. Right now, I'm in this part one. I am interested in only my EMR data, and then this public APIs we call through Databricks notebooks, and we again get it into bronze. So anything that we can get it directly in Parquet, we will put in bronze. We will skip the landing layer. Now, in bronze, everything is in my Parquet format, right? Everything is in my Parquet format. Now, next is I take this data from my bronze layer, this folder, and I clean it. I implement a common data model. I implement slowly changing dimension, and then I put it in silver layer. But now it's not in the files, rather, it's in a delta table, right? Delta table where we can even write, perform acid transactions and so on, right? We'll talk more about it once we see that in the later part, but that's how it is. And then in gold layer, we create facts and dimensions. So this is how I do. And the major technologies that will be used will be your Azure Data Factory, and Azure Databricks, right? So there will be a heavy role to move from bronze to silver, silver to gold using Databricks notebooks, right? So most of the logic will be in Databricks then, right? So if you ask me, sir, many people ask me, Sumit, sir, what are the most important technologies that we should be knowing in Azure cloud? I would say Azure Databricks and Azure Data Factory, and these two are the two heaviest portions of this project, the best part about it. But we are using more technologies. We are using Azure SQL DB. We are using our Azure Storage Account ADLS Gen 2, right? And we are using the APIs, whatever. So we are using various things here. I hope this is clear. And towards the end, what's our end goal as a data engineer? Do we have to do visualization? No. Or reporting? No. Our end goal is create facts and dimensions so that my reporting team can take care, and that will be in gold layer, right? So in gold layer, we have to generate facts and dimension. I want to show you the ERD diagram for that, right? So at a high level, this might have slight changes, but at a high level, this will be the thing. We will have a lot of dimensions. Patient is dimension, diagnosis is dimension. So fact is what? Fact is nothing but a fact, like a transaction, right? And any supporting, let's say, my name is Sumit. I purchased a laptop for $1,000, right? Which is a MacBook. I purchased it from a store in Bangalore, let's say Indranagar. Now, the actual fact here is the amount, that is, I purchased something for $1,000, right? That's the amount. I purchased two quantities. That's the fact. So, fact is nothing but numeric things like amount, number of quantities I purchased, and so on. And any supporting thing like who purchased, when they purchased, from which store they purchased, who was the seller, right? All of that. Those are additional information for the transaction. Those are dimensions, right? So those are dimensions. And dimensions might change slowly. I'll write it. So if I want to get talk at a very high level, facts and dimension. Facts is nothing but a fact which is a truth, right? Something that has happened, a numeric value. Numeric value. Now, do not say, Sumit sir, employee ID is also numeric value. It should be a fact. No, right? So, ideally, a numeric value like total amount, right? Total quantities, all of this can be facts. So, anything which is a numeric value or a decimal point is a good candidate to be a fact. But dimension is all the supporting things, right? Supporting things. A fact never change, right? But a dimension can change, and that's where we have to implement SCD type 2 to maintain history. We have different types to implement this, right? SCD1 where we do not maintain history, we override it. SCD2 where we maintain history, and SCD2 is what is a industry practice. So anyways, I will close this diagram. We have understood this. uh, this one I was showing. So we have a transaction, fact transaction, right, which is nothing but the fact, and it has a lot of references to the dimensions, you see. So patient ID, we have patient's dimension. Department ID, we have department dimension. Provider ID, we have provider dimension, that is doctor, right? And then ICD code, we have right, this code dimension, right? Encounter ID, claim ID, right? So a lot of this references are there, but we have payer paid amount. These are actual facts. Adjustment amount, patient paid amount, all of this, right? So these are facts. So you can see even these dimensions have link. For example, you see this dim department has a link to dim provider, because a doctor can be in a certain department. We could have clubbed these two, but if we separate, then it's more like a snowflake kind of style where I mean we would have to join these two also, right? Because these dimensions can also relate to each other. Otherwise, if you go with a normal facts and dimension, then a fact can be connected to a dimension. A dimension cannot be related to another dimension. But if a dimension relate to another dimension, that's more like a snowflake style schema, right? So this is what we want to build at a high level. This might have few changes, but at a high level, our understanding is we want to build facts and dimensions After doing all the cleaning, implementing a slowly changing dimension, implementing a common data model, in the end, our end result is this. So that my reporting team can take this and build their reports and all on top of it. I hope we are good. So with this, you would have a lot of clarity now on what exactly we are aiming for. Now, what we have to do is we have to implement the solution, right? So what in this part I will talk about EMR data only, that how to bring the EMR data to my bronze layer. That's the thing I will talk about. And now you might think it's a very easy thing. It can be easy, but the way we will solve it is in a more industry related fashion where we create a generic pipeline. Very, very important. Right? We will create a generic pipeline and you will see how beautiful things will flow. Right? So I want to bring this EMR data to my bronze layer. That's what I would show you now. So now the technologies that we will be using will be Azure Data Factory. For what? What do we use Azure Data Factory? For basically ingestion, because we will get the EMR data through Azure Data Factory, right? And we will put it in our data lake, which is ADLS Gen 2. I'll talk more about it. Anyways, that's the main part. And then we will be using in this project Azure Databricks. So Azure Data Factory and Databricks will be heavily used. We are using Azure SQL DB, and we are using, or we will be using Azure Storage Account, right? And we will be using Key Vault also, not now but later, for storing our passwords and all of that credentials, keys, right? Which is a good thing. So our raw files or Parquet files, all of that, our data will be stored in the storage account here, right? Uh, Raw files or Parquet files, and then Key Vault for storing the credentials so that it does not get leaked, right? And Azure SQL DB is where our EMR is there. We will also create one or two more tables just for our reference. And Azure Databricks is for our data processing, right? That is our ETL, whatever we do, moving it from bronze to silver, all of that, cleaning, implementing a CDM, SCD type 2, all of that will be done through Azure Databricks, right? And we might use more technologies, but at a high level, I just want to give you an idea that this is the stuff. And Data Factory and Databricks are the two most important components that are there, right? Now, first thing that we have to do is we have to create a Azure storage account, right? And in our case, we have created a Azure storage account with the name TTADLS Dev. TTADLS Dev. That's the storage account name. Now we have made it hierarchical namespace so that it becomes a ADLS Gen 2 account, right? ADLS Gen 2, which is preferred for our data analytics workloads or bigger workloads, optimized for those, right? So this we have created. If you see here, if I come on this, so you see hierarchical namespace. So when creating, you just have to check that option of hierarchical namespace and it will become your ADLS Gen 2 account. Otherwise, it will be a normal blob storage. Fine. Now inside this, we have to create containers, right? You click here and create containers. I'm not creating here because it will take a lot of time just to create. So the containers that you have to create are, I'll just mention the hierarchy because you can do the same. You have to create a landing container, bronze, silver, and gold to implement your medallion architecture, right? So you see all of those four folders are there. But apart from that, I have one more folder which is called as configs, which has nothing to do with, with this four. For my medallion architecture, I have these four. Configs is for me to keep some configuration files. So you see, lending, bronze, silver, gold. Configs is for me different, not a part of medallion as such. Right? Now, I want to keep some configuration so that I implement a generalized pipeline, a generic pipeline, or a metadata driven pipeline. I want to create a metadata driven pipeline, right? Which is something which we should be doing, right? That's where I want to have this configs folder. And inside this, I will create a folder called as EMR, because I want to create a generic pipeline for EMR data. So I will go to configs, where is that? Yeah, and EMR. I have created a folder. You can add directory. I have clicked on add directory and created EMR directory, right? You see this. Under configs, I have EMR. So configs is the container inside this EMR directory. Now I will have my config file, which is loadconfig.csv. Inside this folder, I have load config.csv, right? I will show you that. I'll show you this file, and we have this stuff, right? So in this file, I have this. That means database, right? You will understand why these columns, but at a high level, I will explain you. First column is database. That means whether it is Trendy Tech Hospital A or Trendy Tech Hospital B. We have two databases, right, in Azure SQL DB, right? The second column is data source, right? Whether the source is hospital A or hospital B. I mean, this we will use it later. That's why we have, right? This we have created newly a new column that way. Table name. Now we have five tables in our database A and five tables in hospital B, like that, right? So this is database A and this is database B. So five tables here, the first five. So you see, we have DBO. DBO is nothing but the schema, right? In the Azure SQL DB, just like we have app schema, DBO, we can have various schemas, right? So DBO dot encounters. DBO is a default schema, right? In Azure SQL DB. So encounters table, patients, transactions, providers, department, five tables. And then we are talking how we want to load it. Is it an incremental load or full load? So load type is another column that we want to specify, incremental or full, right? So if incremental, then it will see this and do a incremental load. That means it won't redo the work what it has done earlier. If 100 records are loaded previously, two new records have come, only two will be taken care. So any transactional table like transaction or encounter, right? Or even like transaction encounter, mainly these two should be definitely incremental, because these will be having a lot of data. These are more like your fact tables, right? So you see encounter and transactions. Even patients will be a bigger table, so we can have it incremental only. The provider, which is hardly 20-30 doctors and 5-6 departments, this can be full load because this is very less data, right? So this load type is incremental or full. Now watermark. So if it is a incremental table, that means if we have to load the data incrementally, then we have to define a watermark column. That means based on what column we perform that incremental load, right? Based on what column. So watermark column will be applicable for incremental only. So for incremental, here we have modified date. That means any new records after this particular modified date, we consider as new data. So we store the last modified date here, and any new records we'll pick after that. So that is our watermark. So for incremental, modified date here, and if it is a full load, then no need for a watermark column, because we do not have to perform incremental. So only when performing incremental, watermark column will come into picture, right? Based on which our incremental strategy will be taken care. Now, is active. This is a flag where if we make it zero, we say that my pipeline should not, when I invoke this, this particular table should not be ingested. That means this is inactive. That means it should not run for this. When I make it 0, that means this is not active pipeline. Right? 0 means inactive, 1 means active. So only the records with 1 should be taken care. As part of my part 1, I have not implemented that, but as part of part 2, we will do that. Right? So sometimes it happens that you do not really want to run your pipeline for some specific tables for some reason, then you will put mark it as 0. That means you will make it as inactive, right? So this is called as a metadata driven architecture or pipeline, right? And the target path you will understand why we have put, because we'll be putting it to some folders, either a hospital A or hospital B accordingly, right? So you will understand target path, data source, right? That why we have put this. But these configurations we have put so that after reading this, the system knows what to do and how to do, right? So we have this particular file in our config.csv, and where we have loaded under configs emr folder, load config.csv. I hope this is clear, right? So this is about our this particular folder. So bronze, silver, gold, landing, and configs. Everything is clear, I believe. Okay. So now let's come to the most important part now. Let's come to the most important part where we have to implement the pipeline. And the pipeline is what we want. We want to take the data from EMR, that is our Azure SQL DB, and we want to load where? Where we want to load? In our ADLS Gen 2. That means we want to configure or set our data lake, right? That means we want to bring it to a data lake. In what folder? In bronze folder, in form of Parquet we want to bring, right? In form of Parquet format. I hope you can acknowledge this part, that we want to take the data from database and bring it in bronze folder in Parquet format. Bronze folder in Parquet format, right? That's what we want. So we have to create a Azure Data Factory or ADF pipeline for this. So now when creating or configuring a ADF pipeline to ingest the data, there are few components of a ADF pipeline. You remember, in case if you know, link service, right? Then we have data sets, and then we have certain activities, right? And then we create the pipeline. I'll explain all of this. I'll explain all of this to you, right? So, link service and what it is. Link service. So, what link service is? Link service is basically, let's say you have to get the data from SQL database, right? So, you need some connection parameters in order to get the data from there, right? No one randomly can connect to my Azure SQL database, right? There should be some connection string or connection parameters in order to connect to it. So link service says that how do you connect to your source and how do you connect to your target. So we would need link service for the source, we would need link service for the target. So in this case, I want to connect to my Azure SQL DB. So I need a link service for my Azure SQL DB so that I can connect to it, right? And I need another link service to put my data to ADLS Gen 2, the target. So I need another link service for my ADLS generation 2, right? This is for my source, this is for my target. I need connection parameters, that how do I set that, okay, how do I connect to Azure SQL database? How do I connect to ADLS Gen 2, right? These two are there, right? As of now, I mean, there will be more link service, but at a basic level you can understand that these two are definitely required. Now we will also create one audit table, right? I'll write it as part of this pipeline metadata driven architecture. we will create a audit table where whenever the pipeline has run, we will put an entry saying, oh, the pipeline has finished at this time, right? The pipeline has finished at this time, so that we mention the time, so that next time when we run, we try to pull all data after that time. So for our incremental load, that last modified will help us there. So that's where we need such a audit table. I will explain or show you what audit table is, but remember that as soon as our pipeline finishes, we will put an entry to the audit table, and tomorrow we can check, oh, is our pipeline successful or not, what time it has last ran, and all of that. Now, this audit table where I want to create, this will be my delta table. In my Databricks, it will be a delta table. So, if I want to create a delta table and put an entry in that, I need another link service, right? And this link service should connect to what? Should know how to connect to delta, right? Delta lake, right? This should know how to connect to delta tables or delta lake, whatever, right? Whatever you can write. And now going forward, when I would be putting my passwords and credentials in Key Vault, then I should be knowing how to connect to Key Vault, right? So I would be going forward creating a Key Vault link service also. In this case, in this part, I will not create this, but I would create these three, right? One is to how to connect to Azure SQL database to get my data, how to connect to Azure ADLS Gen 2 to put my data, how to connect to this delta lake in order to create this audit, put entry to a audit table, right? Because that is a delta Databricks delta table, right? These three link services I will be creating. Key vault I will be creating in my next part, when I create implement a key vault and all, right? I implement all the things in a better way. So these are link services. So link service is basically a connection string which tells how to connect, right, to a source or a target, whatever it is. Now, another thing that we have, that okay, I am saying, okay, I want to, let's say I'm saying I want to read something from ADLS Gen to my storage account, then I will create a link service. But now I have to say, okay, what is the file name? What is the file path? And let's say the file name, file path, and the file format, right? These things, how will I specify? Using datasets, right? So then we define dataset which says, okay, can I know what's the file path, what's the file name, what's the file format, where I have to put, or in which format I have to put the file. I hope you can understand this. In case of your Azure SQL DB, let's say you connect it to the database, then don't you feel then our role is to tell what database name, what table name, the database name, right? When connecting to a database name, table name, schema name, right? All of that. So that is where we define a data set. That means I know that I know how to connect to Azure SQL DB, but inside this, what database, what table, what schema, that is we define as part of the data set. I hope you have got an idea. Mostly you would be aware, but still I'm giving you an idea so that even if you do not know Azure Data Factory, you should be able to understand this in a very layman term, right? Just have a look at this. So we will. So you understood that why do we create data set? So we would need data set for what? Uh, in case of Azure SQL DB, in case of Azure SQL DB, we would have to define a database name, table name, schema name, like that, right? In case of ADLS Gen 2, we would have to define the container name, file format, all of that. I'll just put it in brackets. I want to give you a rough sense of why this, right? Okay. And then after that, so let's say when we are doing for ADLS Gen 2, let's say your format is, let's say, delimited text. Flat files, right? Flat files is delimited text. So you will create a data set for delimited text, right? Which will again be related to this particular link service. So we are saying what data set it will handle: delimited text, and it will be related to ADLS Gen 2, because either to store the data or to take the data, right? Then if we want to put the data in Parquet format, we can create Parquet data set, right? Parquet, and again this is related to ADLS Gen 2. This is related to ADLS Gen 2 link service. So basically, you should associate a link service to a data set, right? So in this, when we are defining a Azure SQL DB, then we associate Azure SQL DB link service. When we are defining delimited text, right? Then we define ADLS Gen 2 link service, whether it's a source or target, whatever. Same way, when we define Parquet, we define ADLS Gen 2 link service. And when for this Delta Lake, right? We define Databricks Delta Lake dataset for this Delta Lake link service. I'll show all of that to you. Do not worry. Then it will be more clear, right? So we need to have right data sets. So I will just show you this things. I'll just show you. Uh, so I will go to my Azure Data Factory. I go to Home, and I will go to TT Healthcare ADF Dev. That's the ADF I have, right? I will say that that's the ADF instance we are in. I will launch the studio. I've launched the studio, right? And now what I will do, I will go to manage to show you the link services which I have created, right? So now, if you see that we have to get the data from database, Azure SQL DB. So we should be having a link service for that. So here is that link service. Naming convention I will improvise in the part 2. Right now the naming convention can be little weird, but that's fine. So you can see this. Uh, it is to a link service to connect to database, right? And it's always a good practice to say underscore ls towards the end, so that by seeing it you understand it's a link service, right? Naming convention I will talk in my part 2. So then what we have, I have defined the fully qualified domain name for this database. So I will just show you. If I go to home and I go to, let's say, here, right? I have this server name. I have this server name which I have mentioned. You can see this, the server name, right? Now we have two different databases. We could have easily created two different link services, for one for each. But I want to develop things in a generic manner. That means, is there a way that I can just develop one link service, and then that link service will help us to connect to both of these databases, EMR databases, the hospital A and hospital B? That's how I have developed. So what we will do is we will generalize it. I will show how to do. You ignore this for now, right? Authentication type, SQL authentication. My username is SQL admin. My password, whatever, I have given the password. When I implement a keyword, I will implement a keyword here also. Right now, it's a normal password which I have shown, right? Normal password which I have given that time, right? And if I show here, I have given a parameter here, DB underscore name, because I have two different databases, right? One is hospital A and hospital B, right? Two different instances of Azure SQL DB. So DB underscore name, which is string, and now I will pass this dynamically, right? So you can see here that database name, I am saying linked service.db name. That means I'm not passing, I'm saying it, we will pass it later. We will pass it later. So I am saying database name will be basically whatever the value we will give this, but we are not giving the value here. If we would have given some value, my database name would have been taken that way, right? I could have mentioned my database name here, hard coded here, but I am saying no, no, this will be the value of this parameter. And I have not given this parameter because I will be passing it later. I will be passing it later, right? Now later, that means from where I can pass. The wrapper for this would be my data sets. As I mentioned, we have link service and we connect this link service with the data set. That means when defining a data set, we mention the link service. So we have an option that we can basically define this database name when defining the data set. And if we do not give it during data set, then we can do it when defining the pipeline. Because how it goes is, if you think that pipeline is at the top, then we have data set below, and then uh, we have our link service below, right? So if we are not giving a parameter here, then we can pass that in data set. If we are not passing here, then we can pass that in pipeline. So if we pass something here, that can flow here, and then that can flow here, right? So that's how it is. So data set is on top of link service, and pipeline is on top of data sets, right? That's how it is. So right now I have not defined the database name because I want to create a generic one. Otherwise, I would have created two different link services there, which I do not want. Because let's say if there are five different databases. Now, will I implement five different link services? No. It's always better that we pass this dynamically from the pipeline later. And we will see that. I hope this is clear. Keyword we will implement later. So I will just cancel. So you implement, you understood that how to implement this particular link service, because this will act as our source to get the data. So we need to know how to connect to this, right? So we have given the database username, password, right? But to which database to connect, that we will get to know dynamically. Now, now this was our source, right? Now, ADLS Gen 2 is our target where we want to put the data. So, we need to create a link service for this also. Whether source or target doesn't matter, but we need to connect somehow. Whether it's a source or target, it's not our concern. So, link service is required. So, now we have to create a link service for ADLS Gen 2. So, let's see. This is the one that is there. So ideally, I could have given it a better name and it should have been ending with underscore ls, but we will rename it properly in our next part where we will see best practices and all. So now I have given the name for this authentication type. So basically, if I go to my storage account, right, and I let's say uh, go to access keys here, I can show and copy it from here. This is my access key, right? I have put the same access key here, right? I have put the same storage account key here. And before that, I have to give the name of this, right? This URL. How do I get this URL? I will just show you the overview of this and let me show you where to get this. So you go to endpoints and you will get this data lake storage, this one. So you give this URL right here and you give the storage account key. How do you get storage account key? Again, I'm showing you. You go to security networking access keys and here you click on show and then you copy that key, right? I'm not showing you because I want to use it later also, but that's how you copy it and paste it here. And then you can test the connection. This should work. This should be successful. Because not, only authorized person can connect, right? So you see connection successful because we have given the password of it, credentials for it, right? Later we will store this in Key Vault so that the credentials are secured. right? So no parameters as such here, all good. So we have created these two. So for Azure SQL DB and ADLS Gen 2. Now, once we create, we can use it as source or target. That's okay. Anything is fine. But once you have given the credentials, it's anything you can use. Now we should be creating for Delta Lake also, because we will be storing our I mean that audit table and all, right? So Azure Databricks Delta Lake. That's the name I'm giving, Azure Databricks Delta Lake. And what I am doing, so you can see this Azure Databricks Delta Lake. That's one you have to select. So if you see the previous ones, for SQL it is Azure SQL database. So what you have to do, I mean, uh, when creating a new link service, click new Azure SQL database like that. You click and then start configuring. And for ADLS Gen 2, same way you click on ADLS, uh, this one, Azure Data Lake Storage Gen 2, right? So the one, that one is this, right? This is Azure Data Lake Storage Gen 2. You click there and start configuring this way. And now I was showing for Azure Databricks Delta Lake. Now give it some good name, and then now if you have to do that, your Databricks cluster should be on, right? Because you can only create a delta table when your Databricks cluster is on, right? Because this is a delta table that you will be creating. So what I will do, I have, let me go here, home, and I've created a test workspace. Again, not a good name, but right now a test workspace for Databricks. I launch workspace, right? I'm launching this. So the workspace is launched. You can see that I can go to workspaces if I want to see my notebooks and all. I can go to compute to see if any cluster is on or not. So I initially have created a single user, single node cluster, and I use standard F4 which uses 4 cores and 8 GB memory, and terminate after 10 minutes of inactivity, right? So it consumes only zero point 0.5 dbu per hour, the least that I can spend, right? So but make sure you have a termination time and click on terminate after, right? So now let me just start this, so that once it starts, then I can have a cluster on. I can show you how we get the cluster ID and so on. Let's confirm. So let's wait for the cluster to be turned up. Okay, so you can see the cluster is turned on. It took around 5-6 minutes in order to do that. Now, since the cluster is turned on, I can go to my workspace. I could have seen the notebooks before also, but I could not have associated it with the cluster to run, right? So now, uh, if you see audit table, just want to give you an idea that what is the audit table that I am talking about. So we have created this particular audit table. Create schema. So yeah, so if you see, I'll go down actually, because I've written it here. So if you see here, we are creating a schema audit. So generally in Databricks, a schema is nothing but like a database, right? Just like we create a retail DB database and all. So consider we are creating audit as one database, and inside that we want to create a table named load underscore logs, right? And in this ID, which is auto increment data source, we are putting that what's the source of data. So if you can now recall, if I go to my storage account, if I go to my storage account and go to containers, and then I go to uh, configs, right? Now if you see, you can relate that I am saying what is the data source, right? So I will put like hospital A or hospital B, right? Table name, so table name we will put, right? like encounters table or patients table, that which table just completed the pipeline, right? So data source, table name, number of rows copied, we'll put like 50 rows copied or something. Watermark column name, so in most of the case it's last modified date, right? And apart from that, load date, that what time this is last loaded, right? What time it is last, the record is last loaded. So this audit table we will create, and how it helps is that you want to see, did my pipeline ran yesterday successfully, you can go to this audit table and check these logs. This will help you a lot, right? So this audit table, we have created load logs, and in this we will be loading the logs after the pipeline succeeds. So if I show you this, we have created this, right? So now to start with, we will basically, the table would be there, but I would truncate this. I'll truncate this. It has truncated, so that I mean, it should not show anything. But if it shows, it will be like auto increment ID, data source, hospital A, hospital B, which table, how many rows copied, and watermark column name. Only in case of the full load, incremental only it will be there, right? For full load, it will not be. And load time, right? Load time. I'll talk more about it, but right now, if I run this, it should not show anything because we have truncated it just now. We have truncated, right? Nothing is shown. Okay. Now we want to create a link service to this, right? That's how we came here, because not a random person can connect, right? There should be a way. So I click on this. I mean, that means if I have to create a link service, I click on new, and then I type in Azure Databricks Delta Lake and then select that and put this. Now here, what I have given access token. How do you find the access token, right? I believe you can get it here and under settings. Yeah. So settings, developer, and access tokens. You cannot see it later, but you manage and generate new and put it there, right? I'm not doing that because I mean, I've already done. So you can take the access token from here and put it here, right? Put this access token here. But what is this domain and cluster ID? Go to this, my Databricks workspace. So here I will find this URL, ADB, right? Let's see if this URL is the same. ADB 130, that thing, Azure Databricks.net, right? So you see, this is this one. This URL you have to provide. This URL you have to provide here. And this cluster ID we can get from the cluster. So when you come here, you can see either somewhere under the properties, or you can just get it here, right? So if you see this 1107, right? So here is the cluster ID that you have. So go to compute, right? Click on your cluster and you can have it. There will be more ways to check that out, right? But again, that's one of the easiest way, that you have your cluster ID. You mentioned that cluster ID here. So two things, domain and cluster ID, and that's it. That's it. Test connection, it should be successful, of course. Yeah, connection successful. Anyways, I will cancel that. So I've created a link service to connect to my SQL DB. I have created a link service to connect to my ADLS Gen 2. I have created a link service to connect to my Azure Databricks Delta Lake, right? So these three link services I have created. And key vault I am anyways not going to talk now, we will see later. So that's fine. Link services is done. So link services, all the three which were main, we have created, right? These are the three we have done, created. Now we would be creating data sets. Data sets from Azure SQL DB, we have to get the tables, right? So let's create the data sets now. So what I will do, I will click here, author tab. So if you want to create a data set, you click here and click on data set. Select what's your, let's say, are you looking to create it something for your ADLS Gen 2, or you are looking to create it for your SQL DB? Let's say I want to create for ADLS Gen 2, right? Gen 2, right? Now, in this, what kind of file I want to store, what kind of data set I want, right? Delimited text, or let's say a Parquet or whatever. That way we have to create. That means first more like a link service name and then data set name when you are creating this. So let me first see the data set for Azure SQL DB, right? So you can see this, you can see what we are doing. So we have created this for Azure SQL DB, and we have selected our link service for Azure SQL DB. You can see this, right? We mentioned in dataset we have to mention what link service it is related to. So now we understood, we have given our credentials for Azure SQL DB, but in that, what table, what database, all of that, right? How do we know? So that thing. So link service we have selected, and then DB name. You remember last time when we created a link service, we have to give the DB name, but we still have not given. Here also, we are not providing the database name, right? So this is inherited. You see, link service properties. This particular thing is inherited from the link service, and it says you give the value, but we will still not give here. We will get it from the pipeline, which is the third level. So first is link service, then dataset, then pipeline. So let this value come from pipeline only, right? To make it dynamic. So basically, this is a dummy one. Actually, I should have clicked on the proper one which we did for Azure SQL DB, which was this one, generic SQL DS. Because again, our intention is to make generic. So let me delete this anyways. So I'll delete it later. So this delimited text one and Azure SQL table one, these are of no use. So anyways, as part of part two, we will clean these two things. But this is the one that I want to showcase. So when we have created a link service for Azure SQL DB, we are creating data set for that, and that is generic SQL data set, right? Okay. Now in this we selected the link service, whatever we have for our Azure SQL DB. This is the one, and DB name we are saying okay. We are not passing. We are not passing this name, right? You see at the rate dataset dot DB name, right? So still we have not passed, right? So you can see there are three parameters. If you want to connect, what parameters you need, right? If you want to connect to Azure SQL database, right? So we know credentials are set, but we have to still tell the database name, which actually in link service we were supposed to tell, right? In link service only we were supposed to tell. Then we have schema name and database name. Sorry, table name, right? Because if we have to specify and get this, then we have to mention schema name and table name also. So we have two more parameters, schema name and table name. We have not defined the value, we are saying these are of string type. And when I go to connection here, right, you see DB name is something which is coming from link service itself. We have not created newly, it is coming from link service, right? I hope this is clear. And the table name and the this schema and table name that we have defined here as part of parameters, right? So we are not passing the value, we will get it from our pipeline itself, because all of these things will come from our configuration file which we have uploaded in ADLS Gen 2. That's why we were saying it's a metadata driven architecture. So all of these three things, these parameters, nothing we are passing, right? It's all we are keeping generic, right? We are saying at the rate dataset.db name, schema name, table name. We are not passing the value. We are not hard coding. We are saying we'll see it later. Later means from the pipeline itself, right? So this data set we have created, right? Then this is done. this is done Azure SQL DB dataset number one. So in terms of data sets, right? Azure SQL DB we have done, and we have not passed any of these parameters. This one we were getting from link service itself. This parameter we were getting from link service, but still we have not passed the value. And these two new parameters we have created, but we have not passed the value. We will see it from pipeline itself. Now, next data set that we have to create, right? Now uh, we want to basically read our configuration file also. Our configuration file is kept where? Right? Our config file to implement the metadata driven architecture, we have kept created a configuration file. Where we have kept that? That is in ADLS Gen 2. And that file is in what format? A flat file basically. Flat file, delimited file, comma separated, right? Delimited file. So we have to attach this link service, and we have to create a new dataset delimited file so that we can read this configuration file. So I'll show generic ADLS flat file. That means any flat files we will be able to read. So using this generic SQL dataset, any SQL table we will be able to read because we have not hard coded what table name, what schema name. Same way, if any flat file we have to read from our ADLS Gen 2, we will use this dataset, generic ADLS flat file dataset, right? I hope this is clear. And what link service we have associated? Azure Data Lake Storage 1, right? That link service we have created, right? We have associated that. Okay. Now, in this, we have to tell from what file we have to take. Like, what we have to give is the uh, file path, file name, and apart from that, container name. In order to read this, we need all these things, right? So as part of link service, we know the credentials to connect to ADLS Gen 2. But now we have to give more details that, okay, what's the file format? File format is delimited file CSV, right? So we mention in this data set. What's the container name from which we read? What's the file path from which we read? What's the file name? All these things we define as part of the data set, right? So you see, we have associated the link service and this container. So we have defined container, file path, and file name as the parameters. All of this string type. And now we are just saying the file path. From what file, from where to read? Again, if you see, it should be landing, that's the container, slash. Inside that, we have created a folder EMR, that's the path. And then inside this, the name of this file was the name of the file. If I go and check quickly, it was uh, so configs EMR, not landing, sorry, configs EMR, and then load underscore config. So configs EMR load underscore config dot csv, right? So this is nothing but the container name. This is the file path, the folder name, and this is the file name, right? So we have defined. You can see this, that we have defined basically all these three parameters: container, file path, file name. And here we are saying dataset dot container, dataset dot file path dot file name. That's the total path from which it has to read. But these things I'm saying I will pass from my pipeline itself. I'm not hard coding here. I'm not hard coding because I'm naming it as generic. That means I should be able to use it for any kind of flat file then later, right? And no compression, comma separated file, all of those things, details related to the file. And first row is a header. So we have mentioned that, oh, it's a comma separated file, first row is a header, and uh, how to read. the container, the folder name, and the file name. Right? I hope this is clear. So we have created this also. So this will be able to read any flat file. This will be able to read any table. Right? We have created generic way. Now, what other link service we need? Now, we take the data from Azure SQL DB through Data Factory and we load it to ADLS Gen 2 in Parquet format. So we also need in ADLS Gen 2, in ADLS Gen 2 link service, we need Parquet, Parquet file, right? So Parquet data set we have to create. So generic ADLS Parquet data set. Just like flat file dataset, same way Parquet. It also connect to same link service, which is our storage account, ADLS Gen 2. And here we have given the parameters again same way, container, file path, file name. Same way, just like we have given for our text delimited. But here the file type is Parquet. We have selected Parquet when creating this, right? So for example, if we have to create this data set, right? I will just show you uh, gen 2 and then I select Parquet here like that, and then I continue and do all of that. That's how we have done. The only difference is this file is Parquet here, and the compression type is snappy. And again, container, file path, file name, I'm saying okay, let it come from pipeline because it's a generic thing. I'm not hard coding these values here. So this is also set. So we have created a data set, generic data set for Azure SQL DB, a generic data set for delimited or flat file, a generic data set for Parquet file, right? Associated the link services also, right? So these are the three that we have created. These two are dummy ones. I will delete it later. Now, when writing to the audit table, right? Audit table, that means my, if I have to say Databricks Delta Lake, right? For that also I have to create a data set. So that's one that I have created. Azure Databricks Delta Lake data set, right? I created associated that link service, and if you see the parameters, when I am writing something to that or reading something from this, I need two things. One is schema name and one is my table name. So I have these two parameters, schema name and table name, both of string type, not passing the values. And this database and table name will we will get from, so schema is nothing but like a database name. As I mentioned, schema name is nothing but database name. When you talk about your Databricks, schema and database is synonymous. Right? So this is again we will get from pipeline when we run the pipeline. So we have created four data sets that we want. So link services is done. On top of that, we have created data sets. Now we will create the pipeline. We will create the pipeline and have activities inside that. That's how it is. So now comes the part of pipeline. How to create pipeline otherwise plus pipeline and pipeline create, right? So if you see, I come here pipeline. Okay. Now I will show you this. What does that mean? So first of all, so pipeline is made up of activities, right? Pipeline is made of activities. Now, the first activity that we have is a lookup activity. You select from here. So if you just say lookup, you bring it here, right? So I got it, lookup activity. So basically, what it do is it looks up for a file. So if I basically show you this, what we have done is I gave it a name, give some proper name. So what this will do, this will read the config file. So the lookup activity lookup activity will read the config config file. Config file is where in config folder, emr config container, emr folder, and we have that file. You remember this path we want to read. So this is nothing but the container name, this is nothing but the file path, this is nothing but the file name, right? I hope this is clear. So let's see. So if I go to settings, if I go to settings, you can see here. I select the data set, right? In when creating data set, we put the link service. But now when creating pipeline, we put the data sets, right? So what data set? I mean, since I have to connect to my config file, that's my that's my flat file data set, right? Generic ADLS flat file data set. So generic ADLS flat file data set. Now, three things that I have to mention: the container name, the file path, and file name. Container name is configs, file path is EMR, that's the directory, and file name is this load configs. Right? We were avoiding to give these details, but now finally we have to give that. Right? So it reads this, and you can see file path in dataset. So it forms the complete file path. Recursively, it reads this file. Recursively, it reads this file. I hope this makes sense. You can just check this out. Right? Okay. I think you should not have any doubt. I mean, if you want, you can preview the data, but it will start a small cluster, right? So you can see this. I'm doing a data preview. The data preview session would have been on, right? Okay. I hope this should be pretty much clear to you. So when you preview the data, it will start a small this thing cluster in order to see that. So if you see, right, you can see your config file that you have. This was the same config file, right? That okay, which database, data source, table name, load type, incremental or full, watermark column. So watermark column will be in case of load type incremental only, right? Is active. Right now I have not implemented that. Even if it shows 0, the pipeline will still be running for that, right, when I run. And target path, hospital A or B. Okay, so that's fine. I hope this is clear. Now, this file will be loaded like that. And now, after that, for each entry in this file, that means for each entry in this file, so we have how many? 10 entries, right? We have 10 entries. Now, we are using a for each activity, for each. So, if you want a for each, you just search for each, right? This one. So for each entry in this file, we want to do this, right? All of these things, right? So this for each will run in a loop 10 times that way. Let me click here now just to see what is there. For each entry, that means for the first line that it reads, the line that it reads, let's say, would be like this, right? Initially. For this line, it will do all of these steps. So first it checks that okay, file exists. So this is a get metadata activity. You can search this activity get metadata, right? So what this get metadata activity do it is it checks whether this file, let's say, it checks whether there is any file with the name, let's say, encounters, because first row was this encounters, right? So is there any file with the name encounters which is there in our bronze folder, bronze folder, right? It will check that. So how it checks, you see, if it has to check something in the bronze folder, and of course now it is checking for parquet files, because if the pipeline has run earlier, it would create parquet files only, right? For this, you will understand that later. So what data set that we want to see here, it is generic ADLS Parquet DS, because we are now looking for Parquet files, right? Related to Parquet files now, right? So we have this Parquet data set here. Now, container name bronze. So, for example, if I uh, go to this and I go to bronze container, bronze. So you see inside inside this hospital A, inside this hospital A, is there any file with the name, let's say, what was that name? Encounters. Because first file was that, right? Encounters.parquet. This would be .parquet file, right? Anyways. So if you try reading the data, it will show in some random format. There is a lot of data, so yeah, anyways. So we want to see, is there any Parquet file present inside a bronze container, right? Bronze container and uh, hospital A or hospital B folder, right? So if you go to this particular thing, you see container bronze and file path. File path is nothing but when we ran. So if I go one step back here, when we ran this, right, it gave me it gave me this particular data, right? This particular data. Now in this, if you see that table name is nothing but this, data source is hospital A, and target path is host A, right? All of these entities we get as part of item. So let me go here and show again. Now it will be more clear. So you see, at item, that means whatever we got from the previous step, at item dot target path. Target path, you see this. What is target path? In this case, HOSE, right? So that means this will dynamically give you a value of HOSE for the first line, right? So file path will be, so I'll just write, container is what? Hard coded as bronze. You see this, container bronze. File path is what? File underscore path is nothing but whatever this at item. That means whatever previous tab has given this particular line. So I will just copy this here, right? So previous tab has given this particular line, first line, because it's iterating one by one. So target path is nothing but HOS A. That means hospital A, HOS A, right? And file name, file underscore name. We are saying item dot table name. Item dot table name is what? This one. So we get this, sorry, this one, right? And in this, what we are saying, split based on dot. So if we split based on dot, we get items of 0 and items of 1. So this encounters will be items of 1. So we are getting of 1, that means we get encounter. We are getting rid of DBA, right? So that means file underscore name is file underscore name is what? Encounters, right? That's how dynamically we get this from the first line. Now we are getting this. That means container bronze, file path this, and encounters. That means what it's checking that whether this a file with this name exists or not. And since we have selected Parquet DS, that means automatically it will check for Parquet file, right? So a file name slash bronze slash hospital A slash encounters dot parquet. That means when previously we would have run the pipeline, we would have got a file like this, right? Now, same case is there actually. So if you see here inside container, we have run the pipeline earlier. So in bronze, Jose, we have all this because our pipeline was run earlier. So now when we run next time the pipeline, it sees that this is there, so we should move it to archive. That's what we are planning to do now, right? So it detected that, oh, this is there, so before we invoke it again, let's move it to archive. That's what we are doing, right? So exists, if it exists, right, if it exists, then what we do, right? If it's true, that means if the file exists, right, then what we do is we basically, so I will write it here, if the file exists, that means if it is true, right, what activity we are running for that, you see this if condition. So activity is if condition, if exists, right? And if condition is true, then what we are doing, I'll just show you that. If it is true, then you think what we want to do, we want to move it to archive. From where? Source is this. So uh, source is this, and target would be what? Target would be, the container is same. Let me just take it and modify. uh, Container would be bronze, right? Then in that archive, and inside this also we are creating a hierarchy of year, month, and day, right, before archiving. So archive, and in this year, month, day, and then finally we put the file. Finally we put the file, right? That's what we are doing. So let's see how we have done that. Source anyways is container bronze, target path which is host A, and file name which is encounter, right? You know that we are, this is our source. But sync, whatever target is nothing but, you can see again we want in Parquet, so same dataset, Parquet dataset. Now container is bronze, and you see the file path. We are saying item dot target path. What was target path? Host A, right? Host A, right? So you can see this. After that, we are saying archive. So before this, host A also, and archive, and then we are getting the current time using UTC now. So it gives me current timestamp, out of which I am extracting the year, right? Year. I'm extracting the month, and I'm extracting the day, right? So this is my path. So the path is nothing but the target path slash archive. That means target path, which is nothing but host A or host B, archive, year, month, and day. For, it gets the current timestamp and extract the year, month, and day, and that's my file path. And after that, the file name is nothing but whatever item dot table name, and separated by this. So same we will get encounters. So we are getting this. I hope this is pretty much clear to you, right? So you see, it's a similar path. It's a similar path. If I basically go here, containers, bronze, so host A, then archive, right? So before archive, this was there, right? The target path was there. So I hope this is clear. Okay. So this is fine. We have, so in case if the file Parquet file was present already, then we are moving it to archive so that when we run it newly, it should not collide with that, right? That's what we are doing. So this is taken care. If it was true, we are doing this. If it was not present, then nothing. We do not have to do anything then. So only if file exists, we are doing this particular thing. That means when it is true, we are archiving the file. We are archiving it. And for archiving, I have shown you this code. Otherwise, no need to archive, because only if it is present, it is archived, otherwise, no. And once it is archived, then we have to do the remaining activity. That means we have to get the data from. So the flow was the flow was first read the config file, right? Iterate over each entity one by one. In our case, 10 entries are there. So 10 entries were there. So it will iterate over each entry one by one, right? Using for each, right? And for each entry, it will try to run the pipeline. And we saw that the first entry was this, let's say. So it read this, and then what it saw, that if the parquet, if the uh, encounters dot parquet file is present in bronze folder, right? Then we move it to archive before doing any other thing. And then after moving to archive, if it is present, move it to archive and follow the remaining steps. If it is not there in archive, if it is not present, then no need to archive, because uh, it's not there, and follow the remaining steps, right? What are the remaining steps now after archiving? Now what we want is, take the data from Azure SQL DB and put in bronze uh, bronze container, right? Bronze container. That's what we want, right? So take the data from Azure SQL DB and put it to bronze container. Now that means, when you have to take from Azure SQL DB, what data set you will use internally? So something we have created for Azure SQL database, right? We have done. And when we have to put to bronze container, we have to put in Parquet format. So Parquet generic, right? So this will be for my source, and this will be for my target, right? These data sets I will be using. I'll show you that. So you see, now next step is, you check basically if it is a full load or not. If it's a full load or incremental. How you will check? Because you get this entry, right? In this you have this load type, incremental or full. So you get items dot load type. And if items dot load type is incremental, we have a separate strategy. If items dot load type is full, we have a separate strategy. That's what we are doing. If condition, if condition, and you see this, what does it say? What's the expression we are giving? We are saying equals item dot load type full. That means, if load type is full, that means if it is true, do this. If it is false, do this, the below one. So let's see, in case of true, what we are doing. That means, if load type is full, right? If load type is full, what we need to do? I'll just show. If load type is full, what we need to do? We basically take all the data from Azure SQL DB, the entire table data. That means, like, select star kind of from table, right? And take it and put it to our Parquet file, right? Select star kind of thing. There is no logic of the watermark column and all. So let's see, very simple logic. So if you see here, I show you the source. Source will be what? Azure SQL DB, right? So that is SQL data set, right? Generic SQL data set. Now we have, when we have to sources uh, SQL DB, connections and all were given in link service, but still we have to give three things: the database name, right? We have not given that. The schema name and the table name, right? We have to give these three things. We have not passed it earlier. Now how do we get the database name? The database name, so we get it from here. We get it from here, the database, right? That, okay, it has to read from Trinity Tech Hospital A. So that is items dot database, isn't it? How do we get now schema name? Schema name. Schema name will be schema name will be we take this table name and kind of split it based on dot and then of zero, right? This particular part. We extract this first part from this table name. And how do we get table name here? We extract the second part from this table name. So items dot database will give the database name. Items dot table name split of zero will give this schema. Items dot table name split of what one will give us this table. So we get all of this. Items dot database, items dot table dot zero and one. So this is how we are getting these things. So we are not putting it. We are getting this line from configuration file and it's automatically taking from here based on the configurations, metadata driven architecture, right? Okay. And it connects to this table. What it has to get from the table? What it has to get from the table? It has to just say select star, right? It has to say select star. Uh, Apart from that, we get all the columns from the table, whatever. Apart from that, I want one more thing: data source. Item dot data source. Item means whatever this config file has given dot data source. It will give me host A or host B. So just for my reference, in my Parquet file, I want to have one more column that, okay, what's the source? Is it hospital A or B? So that is again added, hospital A or hospital B as data source. From from what? Item dot table name, right? From item dot table name. I hope this is clear. So we have given a query and this will get all the data from counters table. It will, let's say if it has 10 columns, it will bring all 10 columns, plus it will have one more column which is nothing but the data source like host A or host B. That means we understand that whether it's coming from hospital A or hospital B. So I hope this is clear. So now once the data is copied, what you want to do? We mentioned, right, we are maintaining a audit table so that we can keep a entry for, I mean, once this is done, we want to add an entry in the audit table. So now audit table is nothing but your stored in your Delta Lake, right? So if I go to settings, you see Azure Databricks Delta Lake dataset, right? And this schema and table you can provide randomly because you are providing a query. See, if there are two ways, either you provide the schema name, table name, and you can select table here, or when you are giving query, this does not come into picture. So what we are doing, right? I take this and just talk about it, right? So we are inserting into audit. Audit was the schema. This was the table name. We are storing the data source, the table name, number of rows copied. All of these columns we are storing. Now we have to put the values. What values? So data source is what? Item dot data source. We got it from the config file itself, right? This one, this whatever we were getting was item. So item dot data source. So many things we will get from that. So item dot data source, item dot table name we are getting from this again config, and whatever previous activity ran, right, in terms of copying the data, that full load activity will also tell that how many output rows copied. So activity name dot output dot rows copied will give us how many rows copied. Items dot watermark will, from that config, it will give me the watermark table column, I mean, right? And UTC now. Anyways, watermark column and all does not come into picture because it's a full load. And UTC now is current time. That means at what time this pipeline has finished for this particular table. So that's how I am putting each, after this finishes, I am putting an entry, right? I hope this is clear. Let me see if my Databricks cluster is turned off. Yeah, that's fine. So I hope this is clear to you. So you understood about the full load, right? You understood about the full load. So how the pipeline was for full load was, we saw the config file for each entry. Let's say we are talking about the first entry now, right? If the file is already Parquet file is already present, we archive that. After archiving, we see whether it's a full load or incremental. If it is a full load, we come here, right? And we kind of take all the columns apart from that one extra column, and we create a Parquet file. Once that is done, then we put an entry in the audit table, which is in Delta table, right? Now, in other case, when this is not a full load, right? When full load is, when this particular thing is not correct, equals item dot load type full. When this is false, then it will come in this part, this false part, and that will be our incremental pipeline where watermark column will be handy. So what does it say? So whenever we have to handle an incremental load, first we have to check the delta table. That okay, what's the last time when the pipeline ran, and we have to take the data only after that time. So we have to have a lookup activity. Whenever we want to read something from a file or a table, we have to have a lookup activity for that, right? So we have a lookup activity, and if I go to settings, I am mentioning the data set so that I can read something from my Delta Lake data set, right? This, anyways, I am giving dummy, right? Not required, because when I am giving a query, then this, all of this is overwritten. And now I am just showing what pipeline I am mentioning for incremental, right? For incremental, first I am going and checking the audit table. First step is check the audit table, and this is how we are checking, right? What we are doing. So from audit table, what do we want? The load time. That means when this, or till what time the data is loaded. So what we are saying, select, right? We are saying max load time. Max load time in the audit table, in the audit. So I just will show you the audit one, uh, audit table. Anyways, I have not run it till now. So in the audit, so it will be load time, right? That what time it was loaded earlier. So current timestamp we were mentioning. So only we have to get that and only load data after that time onwards, right? Isn't it? Because that time the pipeline has run. So what we are doing is, what we are doing is, we are checking the max load time from that, right? Max load time. And if we are running it for the very first time, it won't be there. So that's why we are saying coalesce, like, so that if it is null, then please give me a very back date, some very old date. If we are running the pipeline for the very first time, then we will get this. And if we are running it for the second time and all, then we will get the max load time, right? As last fetch date, that means we have fetched the data till this point, right? And this max load date will give us some timestamp. Timestamp means date along with some time, but we are casting it to a date. So if we are getting, let's say, yesterday's date along with some time, then it is truncating to date only. It is removing the time part of it, right? Now, where data source, right? Data source is item dot data source. We get it from the config file, right? Item means we get it from the config file, and table name equal to item dot table name. So this will be item dot data source. If you see what it will be, uh, host A, and table name will be dbo.encounters, right? So I hope you understand that you can get the data from this particular audit table. You can get the data from this particular audit table, because you remember we have created a schema also. The schema was either this, right, host A or host B, right, which is nothing but data source, right? So we are appending the schema and the table name, right? I hope this is clear. So from this audit table, right, we are getting the record. So uh, if you see this audit table, I do not have the audit table, but these will be the records. So I basically see for that table that data, because a table might be from two data sources, hospital A or hospital B. So I need to check what hospital I am referring to, and accordingly see that particular row, and I have to see the last load time, right? So now once I get the last load time, right, let's say it is some date, let's say today is what, 23rd November, let's say it is 21st November 2024, and sometime 8:54, I mean, do not check the format and all. So let's say this was the last time. So after getting truncating, right, after casting to date, we will just get this part, right? We will just get this part. So we understood that we have handled the data till this part, but now when we handle newly, we handle this date and beyond, right? We will still handle this date again, so that if there is any overlap for this date, that it will be taken care. Let's say uh, we handle for this date again, that means all the records which were processed till 8 p.m. will also reprocess. That's fine. On a safer side, we will still consider equal to or greater than this date, right, next time. So that means all the records which I have processed till 8:54 p.m. earlier will also be reprocessed next time. That's fine, because I want to have a safer approach. Generally, dealing with EMR, the systems are not that great and might have this kind of issues. So I want to be very, very safe and make sure, okay, I am ready to reprocess, because anyways, my pipeline will be a idempotent pipeline. It's not that if I reprocess or reload, it will create issues or create duplicate records. It won't, right? It will merge it. My pipeline will still have the same results no matter how many times I run it, right? So I still consider for this date and any other date beyond that. So let me go here, right? So from the lookup table, I understood that when last I read that, right? And after that, I can now implement my copy data activity. In my copy data activity, I will use this particular date, whatever I have fetched. So in copy data activity, what data sets I will use? I will use something for SQL dataset, SQL generic, and I will use Parquet. So source will be SQL dataset, because I have to read the data from SQL, right, DB. And now again, the database name, the schema name, the table name that I have shown for full load also, same way we are getting. No change, right? No change. And the sync, that means the target is the Parquet data set, right? So we have to load it to bronze container. So we have to load to bronze, and inside this, where we have to load, uh, we have to load to the target path will be either your hospital A or hospital B folder, right? Uh, target path, that's a folder, right? So if I have to say this target path, and inside this, the file name, file name anyways will be, if you just take this table name, you get this, split this and get the second part, encounters. We have seen that earlier also, right? So you kind of understood that we load it here. And After loading, right? After loading the data, you can see this query first of all to load. You can see this query to load. I am selecting select star and additional one more column for my reference as data source from item dot table name where, right? So from this table where item dot watermark greater than or equal to this particular date, right? And this date was, I mean, how do I get this? I have fetch logs activity, right? Just now I have the previous activity. This is fetch logs, right? From fetch logs activity, the output and the whatever first row I am getting, right? From fetch log activity, the output first row whatever I am getting, and in that this column, last fetch date, right? Last fetch date. So this is nothing but this particular last fetch date, and this is how you have to give activity fetch logs dot output dot first row because only one row, right? And last fetch date. This column name. So row name, column name, right? And that's how you are saying that get me only records after this particular date, and this date will be, let's say, replaced with this after or equal to. So whatever you have processed might come again, but since later, I mean, you would implement your slowly changing dimension and all, it will merge properly. You do not have to worry. I hope this is clear, right? So this is our incremental, and watermark columns help us here. And once all of this is done, of course, then you have to again go back to your delta table, right? And store this last, I mean, current timestamp so that you say, till now, I mean, sorted all the data taken care till current timestamp. So after that, to write again to a table, you have a lookup activity, right? Lookup activity, and again the data set will be your delta, right? Delta lake data set. And this anyways dummy not required because when we are writing a query, right, this is all fine. And now I take here and show you this. So finally we update this or add one entry to this audit table. Insert into audit dot load logs, right? So we are inserting now, right? And we have this column names, what values? Item dot data source, that means the config details from the config file, whatever we are getting, and activity incremental load CP dot output dot rows copied. That how many rows were copied. So I mean, once we get to know about this activity, we can get output dot rows copied, right? And what was the watermark column? And the UTC now. That means the current timestamp we are mentioning. That means all the data sorted till current timestamp. That means all the data we have taken care, loaded till the current timestamp, right? And that's how we add a entry to the audit table. I hope this is clear. So now let me go back, and with this you can see we have taken care about it. So how this pipeline flows? First you read the config file. So whenever you have to read a file or a table, lookup activity, right? Lookup, and then anything if you want a true or false, then if condition, right? And if you want a loop kind, then for each, right? So all of these things. So if you see lookup activity to read from the config file stored in AD less than 2. Then for each entry, you have this for each. And then for each entry, what we are doing, again, get metadata to understand what elements are there, right? Uh, if the file was present, then we archived it. And after archiving, we see whether it's a full load type or incremental using the config details. And if it is full load, we kind of take all the data, put it, dump it in a Parquet file, and update the audit table. If it is incremental, then we first fetch the that what was till what time we have loaded the last time we loaded, right? We get that, and then we take all the data after on and after that date, right? And then we then again finally update the this thing audit table again. That's how we have designed this pipeline. Now, in order for me to run this, uh, right now you see audit table is clean. Now I can definitely run this thing. So to run this, what I will do, uh, I will uh, I will basically go to the pipeline, and I will say add trigger now, and I will run. Okay. Now this will start. I can go to the monitor tab and start monitoring this, right? So this you can see will start. Now one challenge that is there with our current pipeline is there are 10 entries, right? That means 10 data sets will be loaded from the tables, or 10 tables will be loaded one by one. So there are two options. It could have been done sequential or parallel. For parallel, anyways, we need more resource, but that's a different activity. But right now, our pipeline is sequential. Now you might say, why, sir? Why sequential? The thing is that the thing is that when you see our audit table, it has this ID which is a auto increment column, right? So in parallel, we cannot update this. In parallel, this cannot happen. Only in sequential, this can happen. And in my part two, we will solve this problem and we will make it parallel, right? Because it should not be sequential, because one table is not dependent on another. So it should not be sequential. So this is one of the limitation, that this is sequential right now, because with this auto increment, if you try to update this auto increment in parallel, it will fail, right? So that's why the pipeline is sequential. And how do you make it sequential? When you go to the pipeline, when you go to the pipeline, I'll show. So you can see under to settings, we have checked this sequential. If you do not check this sequential, it will be parallel, but it will fail because of auto increment, that each thread will try to update that, right? That will not happen. So we will solve it in our next part, but for now the pipeline is sequential. If I go to monitor tab, the pipeline will be running, right? The pipeline will be running, you can see, right? So anyways, when it runs, I'm not sure if our cluster is on. Um, the pipeline might fail also because our cluster, Databricks cluster, might not be on. Let me quickly turn that on, the cluster on. Compute. Okay, it's automatically trying to turn that on because we are trying to see that, right? So it will try to turn the cluster on in this case, and once the cluster is turned on, then it will be able to write and read from this delta table, right, which is the audit table. So that's why all of this is waiting for now, because this fetch logs is not will not happen, right, until the cluster is turned on and we are able to see that table. So it is trying to turn on the cluster, whatever we had. So let's wait for it. By the way, if you have been watching this video and enjoying this, please make. So initially, when we are running this, the audit table is empty, right? So any full load, anyways, will take care. It will happen normally, but the incremental, it will take 1990 as the last time when it ran, right? Because we use coalesce function. So let's see if cluster is created. Things will happen now. things will happen now. You can see things are in progress and things will happen soon. Now, if cluster is created, then I will go to workspace. I will go to audit table, and I will just say select star. Earlier we saw nothing was there. Now also nothing might be there, but it would be working towards that. Once any of the table is finished ingesting, it will have the entry here mentioned. So you can see fetch logs has worked because the I mean cluster is created and it would be able to read the delta table, right? So right now incremental load is happening because the first table itself was incremental load. You remember, right? That was the encounter table. That was the incremental approach we have to follow. So it is, you can see incremental load CP activities going on, and it has around 10,000 record, and we have very minimal resources, so that's why it's taking time. So this pipeline will take some time to run because it is sequential first of all, right? We will make it parallel later. So anyways, let's see. I think probably because of query timeout, let me see. It will try to again run that. It will try to rerun that basically. So let's see if anything has come. Now I can see one incremental load is refresh this, then definitely I should see something because it would write to this, right? Or it's yet to be written. So for incremental load, now insert log. So you see, first it fetch the logs. So how is the flow? So it checked the if condition whether it's a full load or incremental. It saw it was an incremental, so it fetched the logs. It understood when it was last fetched, and after that, what it did, it did the incremental load based on that time. It inserted once the incremental load is done, is it inserted one entry into the audit table, right? Now you can see definitely one entry would be there in the audit table, and you can see this hospital A, DBO dot patients, right? Number of rows copied 5,000, modified date, load date, all of that, right? So this it has done, and I think for some reason when we were first row was encounter, and I think we do not have, we have not set retries, but due to the server took lot of time or the cluster took lot of time to start, so it would have failed because of that, right? So we can check out why it failed, right? But you can see this is working, but now things will happen one by one, and it will take some time, right? Now, if anything else fails, then definitely we would have to look whether it's able to not connect to a database or something. But only that time things have failed when the cluster was not started, right? If anything fails now, we will have a look. Ideally, the cluster should have been running. The cluster was off and we started the pipeline. So let but now we have covered a lot, right? And I am sure you would have learnt a lot from this. Now if you basically see that in our part 2, what I want to show in our part 2, uh, which will be coming soon, and once it comes, it will be mentioned, right? uh, we will implement the silver layer. In silver layer, what you will do, you will take the data from bronze, and you will take the data from bronze, you will clean it based on certain data quality checks. You will implement a common data model. You will implement a slowly changing dimension type 2, and then data will be stored in delta tables, right? Not no longer just plain parquet files, delta tables, right? And then apart from that, we will be implementing a gold layer, implementing gold layer, right? And gold layer where we will be creating facts and dimensions, facts and dims, basically, right? Now we will be also implementing a key vault, implementing key vault, right, as to store our credentials and all as part of best practices. We will improvise on our naming convention, improve the naming convention as per industry uh, conventions, right? We will make our ADF pipeline parallel. Apart from that, we will also see that how to get the data from APIs, right? Whatever we said that we get doctor details and the codes, right? We will see how to get the data from APIs. And apart from that, what we will do, we will understand more about the claims data, because till now we have not dealt anything with the claims data, right? Which insurance provider have put as uh, uh, flat files, right? Now, you remember we have a is active flag 0 or 1. We have not implemented it till now. We have to implement that is active flag implementation, right? And then we have to implement. We can implement the Unity catalog. Right now, our catalog is a Hive metastore. So right now, our catalog is a Hive metastore which is local to a Databricks workspace. Not recommended because other workspaces cannot see what tables and all you have in that, right? So that's where it's always good to have a Unity catalog, centralized metadata repository, so that it acts as a centralized thing and other workspaces can also interact with it, right? So let's see what's happening. I hope more tables would have done by this time. Okay, four tables are done, and you can see two of them were incremental, two of them were full load. So provider and department full load, patient and transaction incremental. That's why we have watermark column, which is modified date, and you are getting that load time. You can see that. So total 10 tables, it will take another 5, 7 more minutes. You can understand that, but you kind of got a gist. So these are the things that I will be mentioning as part of part two. If you feel that it's good to mention some more things, do mention in the comments, right? That what more things you want me to implement as part of part two, because I want this to be a very, very good project. Until now, you would have understood about the quality of this, right? You will generally not get it as part of even paid contents, this kind of project. And this is not a dummy scenario, this is a real world project. Of course, data set we have mimicked, but this is a real world project, and if someone is from healthcare, you would very much relate to this, right? And I was talking about our Hive metastore, right? So if I go to this catalog, you can see we have this audit schema, that is a database like, and load logs, this is our table name, right? This is our table name, and we have these columns. So this is a Hive metastore which you cannot see when you are in some other Databricks workspace. So better thing would have been that if we would have done it or created this audit table as part of our Unity catalog, so that it can be discoverable outside also, right? That's as part of good practice we should have done, which we will certainly implement later. So whatever parts we have missed or where we have not followed best practices, we will try to implement in our part two. So let me see what all is done till now. Uh, so if I go to my workspace and audit table, let's see how much is done, right? Totally six tables are done. Four more are yet to be done, and it will be done. But you understood kind of what is happening, right? So the data would have been moved to archive also. So I guess it takes generally not the, I mean, current IST. Some why, as per those time zone, it will be 22nd November. That's fine, but you see, this is coming in the this particular table. So basically, the data will be taken from Azure SQL database and A or host B, right? Hospital A or B, right? All of this. So you see this file, 23rd. Uh, Now you can see it's 4:42 a.m. actually, right? It's almost morning now. I wanted to release it, so yeah. So you can see this time. You can see, right? So these files have just come now, some time back only. So you can see department, patient, provider, and transaction have come now. This encounter was little later because it failed because the cluster was not up, right? So, anyways, and same way for hospital B also it would be there. You can see encounter, patient, provider, transaction. So almost done, right? Almost done. We can see total 8 or 9 tables would be done. Eight done, right? So with this we have implemented a very beautiful solution to bring it to our bronze, the EMR data to our bronze, right? uh, Now with this I would end this, but before all of that, what I would need is that you make sure you clean your resources. In terms, what I mean to say is that go to your compute, stop that, right? Go to your compute, stop that. Apart from that, ADLS account is fine, it won't charge much, very minimal. Your data factory, even if you have created but not running, then it's fine. So nothing, compute resources is something which you have to turn off, right? So make sure you do that, and then things should be all fine. So with this, we are done, and I hope you would have truly enjoyed the session. Do mention in comments about how you liked it, and subscribe to the channel. And I will come up with the part two very soon with all of these things, plus some extra things which you would mention in the comments, because I want this to be the topmost project on YouTube for Azure Data Engineering. So with this, we are done. Hope you liked it. Thanks a lot.